Okay, welcome back, Year 11s. We're looking at area. Got a nice diagram of area there, which you can read at your leisure. We've got some conversions here. So I thought we could look at these conversions because they're a bit confusing. And I'll just get my pen happening. Oh, come on. There we go. Good. There's my pen. All right. Right, now I can't scroll down. This is a comedy of errors. All right. This is why they're confusing. If you think about something like this conversion here, right? Millimeters to centimeters would look like this. Millimeters to centimeters, you'd say, well, there's 10 millimeters in a centimeter, right? And if I want to go from millimeters to centimeters, I'd have to divide by 10. Or if I wanted to go from centimeters to millimeters, I could times by 10. But that's just in one dimension. That's just a straight line, you know. There's your 10 millimeters. What's that exactly? 10 to make exactly 1 centimeter. But when we turn this into a square, right, so imagine that's a square centimeter. It's not, but you've got an imagination, right? Well, that could be 1 millimeter square. That could be another millimeter square. I mean, you've got 10 millimeters going that way. There's lines everywhere, madness. And then you've got 10 going that way. And altogether, you've got a 10 by 10 here. You've got 100 squares, right? 100 squares. I reckon I can have 2 exclamation marks, right? So instead of 10, you've gone to 100. And what's happening is when we're squaring, we've got to square that conversion as well, right? So 10 squared, that's 100. 10 times 10, same as here, right? So it's easy to forget that. And your conversions look different when you've got areas. They look different again when we've got volumes, right? So just be aware of that. So this question here, go back to this question. I've got 55, and it's got to go from millimeters squared to centimeters squared. All right. Now normally, if I wanted to go to millimeters to centimeters, I'd divide by 10, but now I've got to divide. I'll do a little arrow. Now I've got to divide by 10 squared, or divide by 100, and that will equal 0.55 centimeters squared. Okay, let's look at something a bit harder. This one, millimeters to meters squared. Well, millimeters to meters, we've already looked at this. If I wanted to do the conversions there, all right, from millimeters to meters, I need to divide. I'm going from meters to millimeters. There's obviously a lot more millimeters. In fact, there's 1,000 more, right? Times 1,000. But if they're squared millimeters, you know, a square millimeter is tiny. It's like this, right? It's tiny. Imagine a square meter. It's this, you know, it might be bigger than the table that you're working on, right? Whereas that little thing, that's not table size. You need a lot of those little millimeter squared to make a table, right? So 1,000 squared, millimeters squared, meters squared, everything's squared. What's 1,000 times 1,000? It's 1,000 squared, I hear you say. Or it's 1,000,000, which is 1,000,000, right? Now we're going from millimeters to meters. We have to take this number here, we have to divide it by 1,000,000. I'll do it here. So we've got 4, 6, 170 divide, keep the units, and we've got to convert it to meters squared, all right? And we do that by dividing by 1,000 squared or 1,000,000. Okay, so let's just think about that. That's only in the 10,000s. The millions are over there. So this answer would be 0.04617 meters squared. Okay. So please be careful with those conversions of area. All right, they can catch you out. Now, another one I wanted to look at, 7b2. Okay, well, let's just scroll through the book here. So they're giving us our formula. Right, I've given you a formula reference sheet just the other day. It's up on Google Classroom. Please look at it, use it. You can help write if we do a test next term. You can use it to write a cheat sheet, etc. Use it when you're doing these questions. Have it up on your screen. So there's some examples. You've got all your shapes there. Let's have a look at some of these shapes. What's this? Square, all right? All those sides are equal. Rectangle, triangle. What do we got here? That's actually a rhombus. All those sides are equal, as opposed to this one. You've got two pairs of parallel sides there. This is a parallelogram. That's a trapezium. That's also a trapezium. This is, even though it's got a right angle here, it's still a trapezium. Okay. Areas. All right. Let's quickly do a couple. I reckon this triangle here has the potential to catch people out. So triangle area is 1/2 times the base length times the height length. So let's stop and have a look. Is the base there, is it 3 or is it 5 or is it 2? And the answer is the base is just 3. Well, that's the base of the triangle there. And then you've got to be careful that you use the height of 4. So this area here will be 6. It'll be 1/2 of 3, which is 1.5. 1.5 times 4 is 6 square centimeters. Write it properly, square centimeters. We've got rhombus, parallelogram. Go look up the formula, you can do that. Trapezium, get used to that formula. A plus B divide 2 times the height. This is A, the top. This is the bottom. B, 4, that's the height. Okay, what makes a trapezium a trapezium? You need one pair of parallel sides. Okay, and then we can call it a trapezium. Just going to tidy this up now. I've been scribbling everywhere. How about we do this one, because this trapezium here doesn't have a height, which means I can't use the trapezium formula until I know what the height is, right? So what am I going to do? Maybe think about this. If that's 13 and that's 7, and I've just drawn a line down there. Now I've got a triangle and a rectangle. I think that might help. Let's have a look. That could be 7 down there. 7, I've got to get up to 13. 7 plus 6. Now I could work out that height. And I think I'm going to have to. All right, well, that height equals, well, should we write it out in full or should we go straight to the answer? It equals 10 squared minus 6 squared. All right, now what I'm doing there is Pythagoras. Remember your ABC triangle? and we said a squared plus b squared equals c squared, right? Although I like to write it like this. I like to say c, get rid of that, just equals the square root of a squared plus b squared, because then I can go to the calculator and get the answer with one line of work, right? But that formula is for the long side. What about the short side, right? If you want to find one of these short sides, A or B or H, it's a short side, right? So that's where you have to subtract away, because if a squared plus b squared equals c squared, right? Let's say I minus a squared from both sides, it would mean that b squared would be c squared minus a squared, right? And it makes sense because c's the longest side, right? So if you're adding to c, you must be doing something wrong. That's already the longest. We could say the b squared equaled the square root. Let's go straight to square rooting. It's quicker. The square root of c squared minus a squared, okay? And that's what I've done down here. So that height will be the square root of 100 minus 36. What's that? 100 minus 36 is 64. What's the square root of 64? 8. Okay? Wasn't too bad. So what we've got here, clean up some room, it's getting messy. We've got a height that equals 8. Right. You might have been able to spot this if you knew about this triangle, a 3, 4, 5 triangle. It's your first Pythagorean triple. Maybe I should have drawn probably should have drawn the 3 on the bottom so it matches. Right? What happens if you times everything by 2? You get a 10, 8, 6 triangle, which is what we have here. Right? So if you know a bit of Pythagoras, you could have got to that 8 pretty quickly. All right. Now at this point, I reckon I'll use the trapezium formula, but I could use a rectangle plus a triangle, right? You could go area, rectangle, work that out, plus your triangle. But I just did a triangle. I'm going to do a trapezium instead. So trapezium, right? This is a trapezium, even though it doesn't look like that one exactly, but it's still a trapezium. We've got 7, that's the A value. We've got 13 on the bottom, that's the B value. And we've got our height equals 8. And the formula says you've got to average the top and the bottom. You've got to go 7 plus 13, that's 20. Divide them by 2, that's 10. And then you've got to times them by the height. So 10 times 8, 80 meters. That's quite big. It's like the size of a small house. 80 square meters. All right. So, I wonder how long this video's gone for. We fit one more in. Let's fit one more in. We'll try not to overdo it. We got circles. Yeah, let's have a quick chat about this. They're doing something here, I can see. Look at this. Here, you've got a radius. You use the formula pi r squared, area of a circle, pi r squared. But here, look at that. That's not a radius. Call that a radius. This is a radius, 4.5, right? So watch out for when they give you a diameter, not a radius. And here, you've only got half a circle. So you've got a pi r squared cut in half. You could divide it by 2, or alternatively, you could times it by a half, because doing that is exactly the same thing. Okay? All right, next page. Because I wanted to have a look at 2e, I've got written down. 2e. One more. 2r, slice of circle. Okay. A delicious slice of piping hot circle just out of the oven. So the formula here, it's still an area of a circle, pi r squared, but then you've got to times it by the slice of circle that you've got. All right. Now, if you've got 360 degrees all the way around, but you don't have that, you've only got 67. See, so this slice is 67 degrees, just up to here, out of 360 degrees. So we take our pi r squared, and then we times it by 67 out of 360. Okay, and I just got to remember the radius is 10. We'll go do this in the calculator, I think. Might put the slice first. So 67 times pi times 10 squared, well, that's just 100. It's like 100 pi. Right, 67 out of 360. Can do this in a jiffy. 67. I reckon that'll get in the way of the calculator screen. 67 out of 360. Okay, clear. So we do 67 divide 360. That's the slice. Times pi r squared. So there's your pi times pi. Times the radius. There's the squared button right here if you're wondering. And that will equal, maybe we should guesstimate it first. 100 times a bit over 3, about 300. What's this as a fraction? Oh, approximately a sixth, maybe a bit more. So we've got what? A bit over 300, and we've got maybe 50, 60. Should we get him? I don't know, about 60, I think. Let's have a look. 58.468. Right? Always worth doing a bit of estimation so that you know if you're off. Right? If I get 5,000, I know something's gone wrong. 58.468. Does it tell you how many decimals? When in doubt, right, 3 sig figs. That's the rule for year 12s. So what was our answer again? 58.468, right? 58.468. 3 sig figs, though. 3, what would this be? 3 significant figures. You still thinking? 3 significant figures. Is that a significant figure? Is that? Well, yes, that first one is. Right, so it's not the same as 3 decimal places. 3 significant figures would be 58.5. These are centimeters. Don't forget the little squared. All right, thank you for watching.